So differentiating from first principles. So you can watch the first video to see how we differentiated the others, but I'm going to repeat a bit on this equation. So let's try to differentiate x, this root x, because somebody said it's a bit difficult. So we shall differentiate this, and then we shall also differentiate y equals to 1 over root x. Just see how they differentiate this. So the first thing is to say y equals to, what are we having here? So we bring the changes, y plus change in y equals to root of x plus change in x. Move this y this side, remain with change in y equals to root of x plus change in x minus ry, which is the root of x. So when we reach here, we do what they call rationalizing. We multiply each of these parts by the conjugate. Multiply the whole of this bracket times the conjugate. The conjugate will be when you get this. Now when you put a plus, multiply the conjugate with the denominator and also the numerator. When it also comes and multiplies here, root x plus change in x also plus root of x. Still, it's like we have done nothing, because this and this takes you back to that. So what do you remain with when you multiply this times this? Remember, when you multiply this times this, you remain with x plus change in x. Multiply this bracket times this bracket, remain with plus this times this, but let's use difference of two squares. Remember, this and this, it is the same as using difference of two squares, same as this squared minus root of x squared, because a squared minus b squared is the same as a plus b, a minus b, same as a plus b, a minus. So we are just applying this here. So here we can see that our a is this and our b is this, so it's the same as this over this squared over what I remain with here, root of x plus change in x plus root of x. So change in y, we shall remain with x plus change. This goes with this goes with that, remain with that, this also goes with that, minus x over root of x plus change in x plus root of x. This goes with that, so remember change in y equals to change in x over root of x plus change in x plus root of x. Pull this one down, remain with change in y over change in x. When you pull here, you remain with only 1 over, this is root x plus change in x plus root of x. So as change in x tends to 0, change in y over change in x approximates to dy dx. So what shall we remain with? This will be now dy dx equals to 1 over change in x has tended to 0, so we shall remain with root x plus root x. So how do we add this root x plus root x? Just add what is in front, which is 1 plus 1, leaving us with 1 over 2 root of x. Let's do also this one. I'm telling you y equals to 1 over root of x. So we also introduce the same thing as change in y equals to 1 over root of x plus change in x. We move the y this side, comes change in y equals to 1 over root of x plus change in x minus our y, which is 1 over root of x. What do? We get the LCM. The LCM of this is root of x times root of x plus change in x. So if this LCM times this, what do you, when you get this, the whole of this times this will cancel, remain with root of x. Get the whole of this times the whole of this, we remain now with minus root of x plus change in x. This is change in y. So what do we remain with here? This is now leaving us with this. So at this particular point of time, what do we remain with? What do you think we do? This is changing y, so we have remained with this, which is root of x minus root of x plus. So from here you can be able to continue and get the correct answer. Then you can use it to prove by the other method. So if you cannot continue from here, we shall be able to see that in the next video. Thank you very much.